I'd like to show you why what you see of an IBM mainframe may not change, but the way that you view it will. Most business managers today want to preserve technology investments and to address new business opportunities. What is needed are solutions for total systems integration that make resources of the IBM mainframe and LAN systems available to anyone in the customer's network when they need them. The enterprise systems open and distributed strategy is intended to meet these objectives. Simply put, the strategy describes a cohesive environment where applications in the network can exploit the traditional strengths of MVS and VM using an integrated set of open system services. By facilitating portability and interoperability, open systems enhance the ability to protect investments. But let's take a look at those two words, interoperability and portability. Portability, for many, portability is about applications, being able to run them without any changes. This is important, but portability is also about data and about people and their skills. It is valuable to businesses, for example, to give flexibility in changing systems platforms or right-sizing, to allow the same application to be used across several business units, to make it easier for staff to move between departments and between systems. To achieve portability, interfaces must be standard across systems. To port applications, not only standard languages, but also standard interfaces provided by the system for file and database access, communications, the user interface, and so on. Standardization is rarely perfect, and therefore portability is rarely perfect. It is the level at which the interface is standard which determines the amount and ease of portability. The higher the level, the greater the portability, and the greater the resulting value. In general, the higher the level, the less standards exist. The process of developing standards has mainly worked bottom up. Most companies today have a mix of computer equipment. They also have an urgent business need to enable people to share data and applications across systems. This may be ad hoc, like the retrieval of data for use in a spreadsheet, or it may involve new integrated applications like a banking system that provides a complete view of all customer accounts. The return on investment in systems will be improved by wider access to them, so heterogeneous systems must work together. That's what interoperability means. Most customers now consider interoperability to be their highest priority for open systems. Interoperability is about the ability to recognize and use information within data. Just as for portability, interoperability depends upon standards for functions and for interfaces. And over time, the standards are moving up the levels. Much of the interoperation which is needed and expected by businesses today is above the level which standards have currently reached. The distributed computing environment, or DCE, seems to have such a strong industry acceptance that it is becoming an accepted standard. This enables solutions which address today's requirements and which lead to the standards of tomorrow. However, DCE is no more than a standardized set of low-level system services. Already, standards have progressed beyond that. The Institute of Electrical and Electronic Engineers, or the IEEE, has created the Portable Operating System Interface, or POSIX. POSIX offers specifications for selected aspects of computing at a higher level than DCE. You can see elements of DCE in POSIX and elements of POSIX in DCE. The X-Open Portability Guide, XPG, and the International Standards Organization, ISO, both include elements of POSIX. So you can see that standards are now coming together to form an important infrastructure to deal with computing. The enterprise system strategy is to incorporate DCE, POSIX and XPG. Open Edition MVS combines the power of the personal workstation, the flexibility of open systems, and the strength of MVS into a new environment. It offers new open interfaces for applications and interactive users. With Open Edition MVS, a system has the industrial strength long associated with MVS, and at the same time it gains access to applications and data in multi-vendor systems. You can create client-server applications primarily developed at the workstation. At the same time, many new application solutions will become available developed by vendors, application integrators, and also by users at their own workstations. Applications that you create or buy that conform to the POSIX standards for C programs can be moved with ease amongst computer systems that conform to those standards, such as the Open Edition MVS. With Open Edition MVS, existing applications and data are still supported, and they are even enhanced, and new applications will have access to existing data. Using Open Edition MVS, users can switch backwards and forwards between the traditional interface of TSO and the new Open Edition shell interface, an interface which is completely familiar to Unix users. Skilled Unix users can interact with the system using a familiar set of standard commands and utilities. MVS skilled users can interact with the system using familiar TSO commands and interactive menus to create and manage the new hierarchical file system files and to copy data back and forth between MVS datasets and files. Application programmers and users will have both sets of interfaces to choose from and can choose to mix these interfaces. So you can use the traditional capabilities of MVS as a powerful platform within an open and expanding environment of computing resources where the strengths of MVS, efficient sharing of system resources such as high-speed, large volume storage devices and high-speed printers. A typical MVS system handles massive amounts of data and millions of requests for storage and data every day. Sophisticated data backup and archival, extensive security and auditing, thousands of applications from IBM and other vendors, recoverability and system integrity, and an outstanding record of reliability and service. In the early design stages of Open Edition MVS, IBM had to choose between the integration of open interfaces as a new service in MVS or as a subsystem approach where the open interfaces would be part of the base operating system. It was decided to integrate open interfaces into MVS by building on existing MVS functions. In addition, new functions were added to the MVS base code to support these open interfaces. Thus, DCE and POSIX ship as components of MVS. The additional integrated socket support in MVS TCP/IP coupled with DCE and POSIX provide users and vendors with an operating system where you can easily port Unix applications. Since the open interfaces are integrated into MVS, the installation, operation and administration of them has been integrated into existing MVS products. For example, to install the Open Edition services, SMPE is used. Also, a small number of new commands were added. Open Edition interfaces conform to standards. IBM will also support existing IBM standards such as APPC. You can see in the diagram how the Open Edition MVS POSIX and DCE functions fit together between application programs and the existing services of MVS ESA. POSIX compliant application programs that include C language functions or DCE call statements that as a result of compilation with the C370 compiler or equivalent result in calls to these functions. Some of the functions are performed by these routines alone. For other functions, the library routine calls Open Edition support services or basic MVS services. Pre-packaged POSIX function routines are included in an LE370 C language runtime library. An additional debugging feature, the DBX debugger, can be used to help debug an Open Edition application. Applications can invoke shell scripts, which in turn call shell utility programs. Some of these utility programs make operating system requests and thus are seen from the operating system as applications. Although DBX is not part of the POSIX standards, Open Edition services will provide this because DBX is a well-known utility in many Unix environments. The MVS support for Open Edition services provides process management, file system management, and communications. Process management is controlled by the kernel address space. This is started as part of the Open Edition MVS initialization. The file system is a set of routines necessary to support the new file system type introduced with the Open Edition MVS feature. These new files are byte stream files and they are part of a new file system called the Hierarchical file system, or HFS. Let's take a look at HFS. An Open Edition user can create, store and access data in a hierarchical file system that is already familiar to Unix users and very similar to the file systems of DOS and OS/2. With the HFS support provided by Open Edition, as the name suggests, files are organised in a hierarchical tree-like structure. File names and path names can be much longer than MVS dataset names. Terminals and communication pipes are also accessed as files. And the hierarchical structure encourages users to organise sets of files in a natural way by grouping them by area, by department, or by group, for example. Open Edition allows an end user to access different subsets of files in any hierarchical structure by logically mounting any particular hierarchy. Any hierarchy that has been mounted can be unmounted at a later stage. Files stored in HFS can take advantage of the many MVS capabilities and products, including RACF and DFSMS, to control access to files, to individual users or groups of users, to automatically back up and periodically migrate file systems to archive storage, to define policies for storage placement and the use of file systems, and of course the data integrity that you already get with MVS. Communication services are provided for telecommunications and networking products to be used with or by MVS and generally relate to end-user terminal attachment or from program-to-program communication over a network. So both TCP/IP and ACF VTAM fall into this category. Since its inception, VM has been amongst the most popular of IBM operating systems. It has always spanned the entire range of IBM mainframe processors, from the very smallest to the very largest. Today, it can run from an IBM PS2 system unit based processor right through to the latest 8-way water-cooled ES9000 technology. It has also been demonstrated running on processors with up to 32 engines. Of all the computer industry's operating systems, it is one of the least architecturally constrained, supporting gigabytes of real and virtual storage, up to 64 processors per system image, and thousands of I/O devices and concurrent users. The power and flexibility this offers, combined with the fact that much of the operating system is in source code format to its users, has led to there being over 20,000 VM systems worldwide, with an estimated 9 million users daily. Through the mid-1980s, VM was seen as one of the more open of operating systems, as its users have always had the ability to quickly and easily modify and tailor VM to meet their own needs. It pioneered techniques such as program-to-program communication and concepts such as personal computing, groupware, client-server computing, and local area networking have been commonplace in VM since its inception in the 1960s. However, since the rise of the personal computer and latterly RISC-based workstations running Unix derivatives, VM has been viewed more and more as a proprietary operating system with little to offer to the new world of open computing. IBM has announced a statement of direction to support OSF DCE on VM, as well as selected POSIX standards. By adding support for DCE and POSIX, VM-ESA positions itself not only to be a leader in traditional computing services on which businesses depend, but also to have the unique capability of integrating new and emerging applications technologies. Many companies will have VM as well as other IBM and non-IBM operating environments. These companies will be able to keep existing VM applications that are important to their businesses and also integrate the newer DCE and POSIX compliant applications onto VM-ESA. This allows VM-ESA to interoperate with other environments in the enterprise, letting businesses choose where and how VM can provide specific value. VM has been a strong player in the past regarding open and emerging technologies. Traditionally, it has been an excellent platform for allowing businesses to run applications on VM, as well as develop applications that could be ported to other platforms. With these strengths, VM can now incorporate facilities and interfaces such as DCE and POSIX that will continue to make it a strong player in the world of open systems. Considering its past, present and future, VM is open to nearly anything. VSE-ESA, one of the major System 390 operating systems, has not announced DCE or POSIX support. VSE is evaluating open systems and investigating alternative implementation options, such as a combination of VM-VSE solutions or a native DCE remote procedure call implementation. So you can see, IBM is making a significant investment to open up its mainframe operating systems to the world of client-server computing.
Fourth-generation languages were first introduced in the industry in